Welcome everyone to our next video tutorial where we're going to make the actual PCB for this board. So to switch over to the PCB work environment, it's very easy. You simply go up to the upper left corner and click Switch to PCB Document. So let's look at what we have here. We have the typical inspector on the side, just like we had in the schematic. We can still place components, and we have our design manager, our errors, and our display layers. I like to have display layers on for PCB. And then we have our work environment in the middle. This black area is our board, so we can change its size by dragging this line, and we can even type in the exact dimensions that we want. We then have our components, so I can drag my components onto the board and put them exactly where I want. I can right click to rotate them, and I can middle click to put them on kind of the back of the board. And then these yellow lines are called air wires, and they are connections that we need to make. We'll make those kind of down the road once we have our layout done. Now, typically this is a matter of simply putting our components on the board and kind of figuring out where exactly things need to go. But because we're recreating an existing board, we're going to have kind of defined dimensions for everything. So typically this is a little bit more of an involved process where we have to like drag and move things around to kind of get it exactly how we want. But this time we're just going to type in exactly what we need. So let's click on the top line, and I have this Excel document here with all of our dimensions for our boards. And we can simply type in the numbers that we need. So this is going to be 850. And then for the Y direction, 2040. And then 2040 for that one. And we're going to select the bottom line and make this also 850. And now we have our board layout. So that's the size of our board. Now our Pico is going to be on the back of the board. So I'm going to middle click and put it on the back. And I want to put that at 425 by 1020. Now I don't need this U1, this kind of designator of what the device is, because I kind of know what the Pico is, so I'm going to just delete that. Alright, let's place some more components. For our potentiometers, we kind of know what they are, so I can delete the value and the name for it. I'm going to rotate it once and bring it roughly on the board, and then put the position in. So this is 425 by 220. And then we have our LED and our resistor for the LED. So we want to make sure that the power is coming from one side, going to the other side of the diode or the LED, and then going directly to the resistor. So for instance, if it was like this, you can see the wire would have to go around to this N1 line. So we want to flip it and have it be directly in line with each other. All right, we can delete the values because we know the values, but we do want to keep the names of them. And then let's put these in to what they are. So this is 335 by 495. And then diode 1 is 535 by 495. Okay. Next up is the speaker. So the speaker is 425 by 795. Now it does cover the names. We can drag these over. It doesn't really matter though, because we're going to place these components before we place the speaker, but it's not a bad idea to have those visible. So I'm going to hold Alt And that allows me to do kind of some fine movement to kind of line it up in the middle. All right, let's place our resistors then. So 425 by 1100. Our next resistor is 425 by 1200. And then our last resistor is 425 by 1300. And let's again delete those values. And then bring over the names. All right, then we have our LED, which is going to be 415 by 1485. And then lastly, we have our last potentiometer, which is 425 by 1820. All right, so there is our layout. And we're now going to kind of go through and make sure the wires make sense. So our ground can connect pretty easily. GP15 has a pretty straight path. It's not going in some weird direction. But we see our resistors here. Our wires have to come across to the resistor, and then they have to go to the LED. So it makes sense if we rotate this. So I'm going to just drag it and then rotate it. And do that for each of them. And that's going to give us a clear path for our resistors. And then they're going to come up to our LED. And our middle one is our kind of middle pin. Our outer one is our outer pin. Our closest one is our kind of furthest pin. So that's perfect. And then that looks good. All right, so there's our board layout. Now it's time to connect everything. And there is, you can route manually. So I could like click on this line and click on ground and bring it over and do that individually. And that's often what you do for kind of the beginning. If you have a more complicated board layout, you do that to kind of make sure everything that is really critical is laid out. But there's an auto router that is going to automatically do this for us. And so I'm going to click this drop down on Quick Router and go to Auto Router. And let's see what we have here. So this is if we have different layers of our board. Now we don't. We only have a top layer and a bottom layer. So we're going to leave that on auto. I like to make effort high to give it some kind of more chances to get it right. And then I'm going to click continue and start. And you can see it goes through and lays out the paths. This is a pretty simple board, so it did it very quickly. And we have a couple different options. We have 22 different options. 2 through 22 are various like kind of rules that it follows. One is a completely kind of free-for-all auto router. And so that's the one that's usually the best. A via is a hole. So let's see. We have, this one has 3 vias. So like this is a via here where the trace goes through the board on the bottom. Blue is bottom, red is top. And then pops through to the top and then comes through. Now, vias are kind of a necessary part of board design for more complex boards, but we try to avoid them when possible. They do create some capacitance and inductance, so we're going to choose one that has 0 vias. And the job. And there we go. We have our traces. Now, these are 6 mil, and I want them 6 mil is okay. For the thickness of the trace, I prefer to do 8 mil though at minimum. So I'm actually going to Control Z, undo, and I'm going to go to Rules, and then Design Rules. And we can see we have a whole lot of different options here. And I'm going to change this to 8 for pretty much everything. Actually, our minimum is going to be 8. And then copper width is the width of the actual traces, so let's make that 8. Now I can do custom rules, so say I wanted a certain signal to have like, so say like the 3.3 volts I want to be 10 mil, which wouldn't be a bad idea. I can click that and then add custom rule, and name this, say, all right, copper width. So let's actually delete that. I was on the wrong thing. So copper width, add rule, and I can say is net class sorry, this is a very new thing for me, so it's kind of trying to figure out everything. Let's go to cancel actually and go to net classes and set these up. So this is various like rules for nets, which are the various connections. So I have various nets here. I'm going to add one for power and put 5 volt, 3.3 volt, and ground on one net. Also, VBus would be a good thing to have on there too. Everything else, though, can kind of stay on the default net. All right, now I can go to Design Rules, Custom Rule, and Copper Width, Add Rule, and in net classes, Power, and let's make this 10 mil so that our power traces are a little bit beefier than everything else. All right, let's go back to AutoRouter, and I can continue and start, and then end job, and now you can see, oh, that still made it 6 mil. All right, well, that's okay for now. This board is very low power, so we can kind of let it be for that. But this is going to be our PCB that we have here. I can make it a 3D model by saying push to 3D PCB and push. And it takes a second to load, but then there is our PCB. Now, we do have an issue with our Pico. It didn't load the PCB, so we do need to fix that. And that's going to be in our next video, though. So let's go ahead and save this, Control S, and I can simply, let's go back to our folder, click Save. Done. And there we are. We have our PCB created. Now, thank you for watching this tutorial. If you would please like and subscribe to this channel and this video to help me make more of these tutorials.